Hi guys, as some of you may know, we are building a form builder library for Jetpack Compose. In our team, we decided to create a simple application to showcase the library. So we had one of our friends design a simple survey app and we could implement it using this library. The designs were really cool, but there was one issue. The tab indicators did not have a material implementation. Now, don't get me wrong, the design looked really cool, but we wanted something that can be easily accessible through material design components. From that point, I got the idea to implement this using the Canvas API, so here we are. So today I want us to go through implementing this tab layout and what I discovered. I've been wanting to create a video using the Canvas API, but there are several videos already covering the basics. So I wanted something new and different. But first, let me take you through the design. As you can see, we have 3 screens. As you navigate to each screen, the title appears in the tab header. The indicator radius increases to show the active page, and the title text style also changes. Now, this is easy to replicate using material components, but the problem comes in when placing the indicators and the line connecting them. As you can see, the line goes from the first indicator to the last, and they are all centered below the title header. Another thing we have to consider is the number of items going in the tab layout. In this design, we know it's only 3 items, so that's not really a big issue. We can easily hard code it, but sometimes you need a more dynamic solution. With all that out of the way, let's get to the code. I have a sample application set up in my Android Studio, so go ahead and create one. We first create a composable function that receives 2 arguments. The first one is the current or active screen, and the second argument is the lambda function that will be executed once someone clicks any of the tabs. We then create a state variable to hold the active screen and pass it to the function call. In the onClick, we update the active screen. We also want to see the changes we make, so let's create a preview for that. Then let's create a row and arrange all items evenly. Then we add our text. And in our preview, we can see that everything is fine. Next up, let's draw the indicators or dots below the text. We can use a column for this. The horizontal alignment is set to center and the circle color is also set to black. The initial radius is 8, but when active, we will set it to 12. Let's add all the other indicators. Then check if everything matches in our preview. The next thing is the line connecting the indicators. Since all the indicators are in the same place along the x-axis, we only need to connect the first and the last indicators. Then the line will pass through all the middle indicators too. To do that, we need to know where the first and the last indicators are placed on the screen. Let's create variables to hold these 2 positions. I will use a pair to hold both the x and the y values respectively. The onGlobally position method from the modifiers can help us get the coordinates. It's called once the component has been placed on the screen or its position has changed. We get the component's boundaries from these coordinates. From these boundaries, we know where the component is. For example, bounds.left gives us the starting point of the component in the x-axis, and bounds.top gives the starting point of the component on the y-axis. From these values, we can now get the central position of the component. For the horizontal center, we first get the difference between the right and the left positions. This will give us the diameter of the component. We then divide it by half to get the radius, then add the radius to the left value so that we can get the center. The same radius can be used for our vertical center since our box is square in shape. This can be a bit confusing at first, so let me explain it further. Let's say the left position is 10 and the right position is 20. We need to get 15 because it's the center of the component. To get to the 15, we take the right value 20 and subtract the left value 10. This will give us a diameter of 10, but to get to the center, we need the radius, so take the diameter and divide by 2. We get 5 as the radius. With this, we can then get the center by adding the radius to the left value. The same logic can be applied to the vertical boundaries too. Let's do the same with our last item in our tab layout. With these two positions, we now know where to draw our line. So let's go ahead and add the line using the drawLine function. The stroke width argument defines the thickness of our line. We set the end offset using the values from our end position, and the same case for the start offset. Since we can reuse this logic, let's go ahead and create an extension function for this. When we check our preview, our line is not visible yet. To solve this, we can specify the sizes of our indicator boxes before adding the padding. Then we set the canvas to fill the maximum size of the parent. To add a vertical space, we can make use of the spacer composable. And with that, we have something that's very similar to what we had in the design. The last thing we need is to animate the visibility and the textiles of the titles as we navigate through each screen. For this, let's create a box and specify its dimensions. We can then use animated visibility to conditionally show the title. We also change the font weight accordingly. Let's use this composable in our tab layout. As you change the screen number in your preview, you should see the changes being applied in real time. And with this, we have all the requirements from the design covered, but we can make this a bit more dynamic by providing a list of the page titles and drawing the UI from that list. First, let's create a list of pages and add it to our screen. Then instead of hard coding the columns, let's use a for each loop with the indices involved and use the column structure. Let's change the header box details. Then in the globally positioned lambda, we update our position variables using the index. Then lastly, we update the indicator radius condition. As you can see, you can add all the tab items from our list. This solution is good enough for our use case, but it has some drawbacks. For one, it's not very responsive and can't handle a list with a lot of pages. If you add like 10 items, they will all be packed together and the indicators won't be placed correctly. For such cases, I think the tab layout provided by Material Design is the best option, but that's just one way you can use the Canvas API in Jetpack Compose. Thanks for watching this video, and I'll make sure to post more content soon. Please leave a comment below or raise an issue in GitHub, and I will see you in the next video.